No reason in the world to go back and retrieve those again. As you probably know, network calls and database calls are one of the more expensive things that we do. So we try to be intelligent about limiting that.
Yeah, I think it's nice that it's in here because it's not a contradiction with the first one that you mentioned.
Right.
Because you're like, don't bring it all down. And now we're saying, well, let's not go get, more if we don't have to. And I think that's the key is, do you know the difference between which strategy? And part of that's just, a lot of it's just common sense. But if there's not a need to go back and get something again, but you're going to need it again, you might as well just keep it.
Yeah.
So,
you know those apps that the users end up saying, I don't know why, I just love this app, it just feels great? Mm-hmm. That's a responsive app 9 times out of 10, at least.
True.
It's one of the things that really contributes to an app with significant user joy.
Okay. I felt that way using Code Show, by the way.
Oh, wonderful. All right, so implementing asynchrony is another effort that you can make. Asynchrony is being smart about what you do with the UI thread, what you do with the primary thread and when. And we're going to talk about that extensively. And then finally, besides just being intelligent about what we do with the primary thread, we also want to figure out when it's going to be advantageous to spin up multiple threads. Seems like a managed framework, kind of a .NET thing to do to spin up multiple threads, but actually in today's world, we do the same thing in JavaScript. We spin up multiple threads and let what we call web workers do the work for us in parallel. So, but you have to understand that these are different things. The asynchrony and the parallelism are very different things. And sometimes you want to do one and sometimes you want to do the other. Mm-hmm. You need to know the difference so you can figure out which to do. Now, the first thing that I want to show is a demo that is in Code Show, and it's called scaling. The scaling demo is going to show you what's up with this image scaling, what happens with these assets. The scaling demo is called Scaling, as you might imagine, and when you open it, you see a picture of what I wish was my boat. But it isn't. Now, I'm not sure how this is going to show up. It might be better if you run it on your screen.
Yeah.
But I'm not sure how this is going to show up over the air. But what you'll notice is that on the left, it's the same image, same exact image, but on the left, I've rendered a small version. And I've dropped it on the screen at 417 pixels, okay? In the middle, I've got a large version of the same picture at 750 pixels, width by height. But it's also showing in the same constraint of 417 pixels. And then on the right, I have an image that is using image scaling. Now, the one on the left and the one on the right, you'll probably notice because they have a 417 pixel native version, they look good on the screen. We're currently at 100% scale, so they look good on the screen. But the thing that I want you to note here is that the one in the middle has got some crazy lines, patterns that are going on in the picture because Windows has had to try to scale this one down intelligently and dynamically and very quickly. And so that some compromises have to be made in that image because it's taking a 750 pixel image and it's scaling it down to 417 pixels. Now, can you think of anything else that is wrong with what's happening in the middle there, a large image being scaled down to 417?
Well, it's clearly going to be a waste of resources.
Most definitely. Yeah, here we've got only the need to show a 417 pixel image, and yet we have a 750 pixel image that has to be loaded. So if this is in blob storage on Azure, you're incurring more of the compute cost on Azure, you're taking more space to store it, and you're ending up with something that doesn't even look as good on the client.
Bad.
Yeah. So we want to be intelligent about this. Now, on your own devices, I'm not going to take the time here, on your own devices, you'll be able to open the Code Show project in Visual Studio and run this in the simulator. Okay, when you run it in the simulator, you can go over to the display options on the right, and you can choose to see this in multiple resolutions. And what you're going to see is that the image on the left is at times, when it has to get scaled up, it's going to look terrible. The one in the middle, when it has to get scaled down, it's going to look terrible. But the one on the right is always going to look good. So let's go look at the code and see exactly why that is.
So as you're doing that, Jeremy,
Sure.
I know you're not going to actually run it, but maybe it'd be good to just show where you would launch it as a simulator if you were going to.
That's a great idea. Let me go ahead and do that before I dig in here. So here I am in Visual Studio, and up here on the top is the magic green button that just makes everything work, right?
Right.
You just push that and everything works.
Everything just goes.
Yeah, not so. You push that and it shows you how you wrote your code wrong is actually what happens.
Yeah.
If you drop that down, you get the simulator, you get the local machine, and you get the remote machine. Now, just a note here. Have you used the remote debugging?
I have personally never used the remote debugging, but I have seen it happen.
It is delightful.
It is good.
It is really, really cool. I have a Surface RT, so I'm not even able to install Visual Studio on it, but I install the remote debugging tools, I fire those up, I fire up Visual Studio on my main laptop, and then I do remote machine, and now all I have to do is push the magic green button and it shows up, it executes on the Surface. And as I run through my app scenarios on the Surface, if anything goes wrong, it actually kicks over into the debugger on my PC.
Yeah, that's very cool.
It's really great. That's the remote machine option for running your app. Local machine is what it's on by default and what I tend to run it on most of the time because I have Windows 8 running natively on my machine. But if you run it in the simulator, you just choose, if you want to run it in the simulator, you just choose simulator, and then you hit the green button or you hit Control F5 to run without debugging, and either way, it launches it in the simulator and you get a lot of simulation options.
Yes.
For instance, oftentimes I'll be running on a PC that doesn't have the right resolution, and so I can't show snapping, and so I'll run it in a simulator, and in the simulator I can turn it to whatever resolution I want, and then all of a sudden I can show snapping.
Or a lot of us might be developing on a device where it really doesn't provide another option other than landscape for your screen, you know, a typical notebook.
Right.
But the simulator allows you to flip it around and get that feel for, like, if someone did have a device and they did, what would it do? How would it look? So that's kind of a nice feature of it as well.
I also use it when I'm working on an app that has anything to do with geolocation.
Sure.
It's going to ask your device where it is, and in that simulator you're able to fake it out and say, I'm actually over here, and then you can test with that.
Yeah, and then you start dreaming that you're really there and goes off on a tangent, but I know what you're saying.
It's like being able to telecommute, right?
Sure.
Okay, so that's where you would fire up the simulator, but let's come look at this demo folder in the Code Show project. So in this one I've got a number of image assets that I've dropped right into this folder, and you can see that I've got Catch Small, Catch Big, and then I've got some interestingly named versions of Catch. Now I've chosen these names for a reason. The Scale 100, Scale 140, and Scale 180 are system names, okay? You need to name that. It's a naming convention that Windows chose and we follow in order to tell Windows, I have given you 3 different versions of this image. Now the 100 means that it scales at, when you are scaled at 100%, this is the image that Windows should choose. When you're scaled at 140%, choose this one, and likewise with 180. Okay? The cool thing is that not only do you get the 3 different options, but you don't have to specify these 3 different files when you're defining your image asset.
What do you mean by that?
I'll show you what I mean. Let's open these documents, and let's look at the HTML. Notice I have no JavaScript for this one, so I'm going to jump right to the HTML file. And I have 3 images, as you saw in my UI. The first one being the Catch Small, the next one being Catch Big, and the next one being simply catch.png. So you'll notice that nowhere did I actually refer to the catch.scale-100. So it's not like I'm forced to ask the system what device scale I'm at and then set a condition and conditionally load a different asset. Instead, I just say load catch.png. And then I don't provide a catch.png. Instead, I provide scale 100, scale 140, and scale 180. And the system automatically switches those out.
Wow.
Is that all clear for everybody?
So that literally, that naming convention that you put in there was all it took. There was nothing else that you needed to do that says, okay, now let me go and form it somewhere that I'm doing this. That was all you needed to do.
Absolutely.
Cool.
Yep. As you can see on my HTML, I've got the structure here, and it's just the image tags and so forth. In the CSS, I don't have anything in here about the images themselves, except to position them well in the grid that I drew.
Oh, yeah.
And then in the JavaScript, I've got a whole lot of nothing in there.
Wow.
Yeah, this is basically just an empty ready function. Nothing's happening.
Cool.
Okay, so that's image scaling, and the reason why image scaling can save you some UI responsiveness is because the scaling of the image itself doesn't have to happen. The large and the small version of the picture is sitting there right in your project, and all Windows has to do is check the device scale and switch out and use the correct picture. It doesn't actually have to scale the picture. So that amounts to a little bit of extra speed for you. And by the way, it also amounts to some extra quality for the user.
Absolutely.
So hopefully it will amount to a catch for myself.
Exactly.
In some roundabout way.
Well, there's no promises of that.
Okay, so that's scaling, and that's one way to give yourself good UI experience. Now the next is promises, and if you haven't dealt with promises, you need to go to the documentation and just dive in. Just start at the beginning, dive in, and wrap your head around the concept of promises, because it's an absolutely central and critical process, pattern for you to learn when you're developing Windows 8 apps.
Yeah, in fact, I remember when I was first getting into the whole discussion on promises themselves and trying to wrap my head around it, then all of a sudden I see a blog post by Code Foster over here, and you had a fantastic blog entry that really went into the basics, the reasons why. So if you're trying to wrap around not so much the how, because the how is always easy to find, but why am I doing this again and what problem does it solve? Highly recommend that you go search on promises at codefoster.com. Excellent blog article there.
Thanks, Michael. Now, I've got a demo in CodeShow, and you may have seen this demo already because it's been in CodeShow for a little while, but I added a little bit to it, and it's highly responsible for responsive apps, so it's definitely pertinent. So let's go ahead and run CodeShow. I'll go ahead and jump back. By the way, just a note, it started us there on the page that we were on. If you don't know what the mechanism is for that happening, that's actually a session state saving. It's saving the navigation stack and figuring out where you were before your app shuts down. It's storing that, and then when we bring the app back up, it's restoring that navigation state. So that's helpful. And if you're wondering how that happens, if you're wondering where it happens, go look in default.js. So,
and we'll revisit that when we get to some of our
we
caching
definitely
stuff.
will.
Yeah,
we definitely will. So the promises demo is called promises. I hope that doesn't surprise anybody. And I promise we're not going to use any promise jokes.
Oh no.
No promise jokes. I promise. Here's the concept. Here's what you need to wrap your head around. Why do we use promises? Promises are for asynchrony. Promises are not for parallel tasking. Okay? If something doesn't work in promises, in parallel, promises will not help you with that problem. Okay? Promises are just going to essentially give you a notification when something's done happening so that you can do something else, because that happens a lot. Go get something out of a database, and when you're done, run this. Why? Why do we want to put that off and capture when it actually happens? Because there's no reason for us to just sit there and wait for the database to respond. In fact, we don't even have any idea when that database is going to be responding.
True.
It may very well time out, and that timeout might be set at 5 minutes, 3 minutes. Do we really want our app to sit around with a frozen UI for 3 minutes?
No.
Definitely not. So we want to spawn that function and tell it, by the way, when you're done, get back to me. Here's what to do when you get back to me. That's the whole concept of promises. And I'll try to demonstrate that on the concept section of the promises demo. So on the concept section, we have 3 steps. The first, we have a long synchronous task. So this is analogous to what I just said. You're fetching from the database, and you're waiting for the database to come back before you do anything at all. Watch what happens when I start this 3-second task. the start button freezes in its click state, and my entire UI is frozen for 3 seconds. In fact, after I click this, I'm not even able to hit back until that task finishes.
Yes.
It's a terrible UI. We definitely don't want to show that, okay? So we want to, first of all, make sure that we're not working with a synchronous task that's going to block the UI thread. Instead, we're going to work with an asynchronous task. Now, if you call an asynchronous task and you don't handle it right, it'll call just fine, but it'll come back immediately, and it will not be the right workflow, the right pattern. Your user will say, you're done? I didn't think you were done. I was actually calling the database, and I expect it to take a little while, and you're coming back immediately. So you don't want that to happen. To demonstrate that, look at the long async task without a promise. So this is without a promise. Start it, and immediately that taskbar completes, even though that task takes 3 seconds, believe me. So that's not right. We don't want to lie to the user and tell them that their task is complete when it hasn't actually completed.
Because, I mean, all joking aside, that in itself is also a poor user experience. You fooled the user. And if they actually were depending on that data to be done and it wasn't really done yet, then there will be consequences for that deceptive action.
Right, right. And actually more even than user dissatisfaction, more oftentimes the way this is going to bite you is it's going to bite you as the developer. Because you're going to come back from a function and then you're going to try to use what you just gathered in that function, and it's not going to be available for you. It's going to give you something lovely like, I was expecting an object. Well, you're expecting an object because in that asynchronous function, you were supposed to create that, you were creating that object or fetching that object, and it hasn't happened yet. The UI has moved on, but that thing that we're looking for has not happened yet. So what we want is a long async task using a promise. So let's look at the third one. Long async task using a promise now not only gives me feedback about when this thing is complete, but all along the way, it can give me feedback about progress that it's made. So now let's watch our taskbar. So now each second I can update that progress bar with the progress, and then afterwards, when my progress bar is complete, when my promise is, as we say, fulfilled, our promise is fulfilled, then and only then we can do something else like fill the progress bar.
And I think it's important to note that in that particular example that Jeremy was showing, that was also a true progress, because there are times where we, through animated graphics and things like that, we can give the user the appearance that work's being done, but it might be done in such a way where we're really just stalling them, which is, I'm not saying that's wrong, because if it ends at the proper time, that's great too. But that was actually a genuine progress bar, meaning it was giving real-time, actual progress. That is how far it was along in that stage. And so that always will make for a better user experience.
Yeah, absolutely. Some things that you do, how long it's going to take. We call that a determinate task. And so you put a determinate taskbar on, and your user is going to get good feedback as to exactly how far through the process they are. What is the indeterminate indicator that something is happening?
You tell me.
It is the spinning dots, right?
Oh, that's right. Or the Knight Rider.
Yeah,
it just
exactly.
goes like that. Yeah, that's right. We don't know.
It lets you know that something's happening. It's not like your app has frozen, and that's important to know. It's alive. It's working. It's just not done yet, but I don't know when it's going to be done because I'm dependent on something I don't know anything more about. When's the network going to be responding? No idea. Okay, so that's the concept of a promise, is figuring out how to do something only after something else has happened so that you make good use of this thread, this pipe that you're using as a developer. You're using this processor thread. So how to actually implement and use promises, there are a few different ways to use them, and I broke it down into a few different common scenarios. One is where you're just consuming a promise. So somebody else has written an asynchronous method, and you want to use it. I call that consuming a promise. You call their method, they don't return to you a string. Instead, they return to you a promise that maybe contains a string. And then you get to ask the question, is that promise done yet? And if so, I'm going to do something. So touching start, we'll wait 3 seconds, just like the other examples, and then it will follow through. And so let's go figure out how we do the consuming a promise demonstration. So I'm going to once again go to my Solution Explorer and filter by promises. And that's going to bring me to my 3 components, CSS, HTML, and JavaScript. I love this stack. I love the web platform. You know, we've got this really good separation between architecture, style, and logic. And these pages being composed of these 3 things just makes total sense.
It does.
It's really nice. Okay, so in this page on the JavaScript, I've chosen to break my 3 different sections out as different functions. And so we've looked at the concept section, so I'm going to hit Control-MM and just collapse that. Get out of my way. And let's look at the uses. So with the comment, we can see that this first section is how I implement the consuming a promise example. Okay? So to consume a promise, what do? Well, the first thing that I'm going to do is kind of give myself a little bit of scope to that section of my example, and I'll call that method 1. And then I'm actually passing that scope in to my queue method. That means that I'm doing a query, but only within method 1. I'm limiting my query or scoping my query to that method. That's kind of by the way. So let's look at the start button that's on this first method, and let's give it an on-click event. So let's essentially determine what happens with this button right here, the start button. And here's what happens. A long task async promise is kicked off, and then I'm going to advance that progress bar to 100. So this then is where we're determining what happens after we get back.
Yeah, I think that's key to note that with some chats I've had with other developers, sometimes they feel like that what follows the then that's the running process. I shouldn't have said that. But it's not. It then means now that the process is over, henceforth, do this. Trying to reword it.
We've essentially hit then soup right now.
That's
Sorry.
Right.
Yeah, that's exactly right. We're done. All right. What happens when the promise comes back? Everything inside this function. Inside that function, all I do is update the progress bar. So all I'm doing here is consuming a progress. Somebody else wrote this. This might be an asynchronous method inside the WinRT framework. This might be a call to a database, a call to a network resource. And I don't know how long it's going to take, but I just stem right off of it and say .then. That's consuming a promise. The next one, and notice how it continues after I come back. It's pretty interesting. Passing on a promise.
Oh my.
So this is just a little step of complexity beyond. So I'm no longer just calling an asynchronous method and doing something afterwards. I'm now writing my own method, and I want that method to consume something that is asynchronous, but then I want it to return asynchronously to the original caller. Let's go look at that one. Actually, first let's look at the behavior. Hopefully you're not surprised that it waits 3 seconds and then completes the progress bar. So let's look at passing on a promise. So passing on a promise does the same thing. There's scopes, and then I capture this start button, and for that start button, I want to define my own asynchronous function. So you can see here that I'm just dynamically creating my own asynchronous function, and that asynchronous function returns what it is. Oops, sorry, I hit the wrong key. It returns what it is that long task async promise does. So that's why I call this passing on a promise. I've created a method, it returns the result of another asynchronous method. So then down here is where my actual call is, and that is my async function then. So simply based on the fact that my async function returns something that is async means that in all actuality I should have called this async. That would be more correct. The async, by the way, is just a convention. It means this is going to return a promise to you in JavaScript terms anyway.
So someone looking at that might just say, why not just execute the long task async promise directly?
Well, there may be some work that you want to do in your function. So right here in my async function, you're right, all I'm doing is passing it on, but I may want to do blah blah and a little bit of blah and some blah blah blah, And then I want to return the results of this asynchronous function call. And this wouldn't have worked otherwise.
Right. Thank you.
Absolutely. Now we've got the creation of a promise. So no longer just consuming one from somebody else or passing it on, we're actually making our own. Works just the same way, start, and then 3 seconds later, ba-bam. So it works just the same way, but how are we actually implementing this one? This one, I do the same scoping, and when the button is pressed, here's a function, and here's the call to that function. So I wrote my own function, and inside that function, I'm returning a new Win.js promise. So a promise object is in the Win.js namespace, and it needs for you to define a function for it. And it's expecting that function to have 3 parameters.
That can get a little confusing when
sure
you first
can.
get into this.
Exactly.
So I think you should say that again for clarity.
For creating my asynchronous function, I return a new Win.js promise, but the Win.js promise constructor is expecting that I'm going to give it a function. That function is going to have 3 parameters, C, E, and P, which are themselves functions. So welcome to the world of JavaScript. It's actually nicer in JavaScript, in my opinion, because it's always a function.
Sure.
It's not like a task or a func or a delegate or anything like that.
Right.
Okay, so the promise is expecting a function that itself has 3 parameters that are going to be themselves functions that you can call from inside of this constructor. So now this block of code allows me to do something, and at any point that makes sense, call the C method, and that C method says, you know what? This promise has been fulfilled. I've done whatever, I've come back from the network, I've asked for user input, I've gotten it, I've validated it, whatever. At this point, it's now complete, so I call C, and that completes it. By the way, you can call these whatever they want, so some people use the convention of calling these complete, the next one is error, and the last one is progress. So you can call those complete, error, and progress, and then go change it down here if you'd like, but I am in the habit of calling these C, E, and P. Does that make sense?
Yeah, and I think what's nice to note there is, although that is the definition of what's required in the promise as that argument, when a developer is actually going to consume that promise, they may elect to only supply the complete functionality. So the calling of that promise doesn't actually require that you have all 3 answered, but the creation of it, like you did, does require that you fulfill that contract of providing a function with those 3 arguments.
Yeah, well, and actually, like, this one doesn't report any progress at all.
Right.
So if I were to, on the consuming side of this, try to implement a function for progress, it'd just never get called.
Never get called, because you can see he never has a P open parentheses with anything in there, anywhere in there, so it would just be ignored.
Now, I might find some array. So let's say var a equals, here's an array. It's an array of a few things, and I can for each on my array. And in my for each, I can, this is an array item. In my for each, I can say P. And I can report some progress. It doesn't have to be empty and just say, I made some progress. It can be, how much progress did you make? So I just made, let's pretend that A contains a property that determines how much work just got done. There we go. So now I'm reporting back on each iteration of this array that a little bit of work got done. And now on the consuming side, I'm able to override this function, capture how much work it was that just got done, and advance my progress meter by that much.
Cool.
So inside, now remember, I'm writing my own Win.js promise. Inside of there, I'm giving it a function. That function has C, E, and P that I can call anytime inside. I'm implementing a try-catch block, and inside the try block, I'm going to try to do something, and I'm going to try to send back that the promise was fulfilled. But if an error of any kind happens, that's going to get caught, and then I'm going to call this E function, which reports to the promise you are in an error state, and by the way, here's the error that occurred.
Cool.
So remember that when you complete, or when you report progress, or when you do error, you have the opportunity to pass some object in here. And then that object is available for the consumer. Let's look at the consuming function now. Let's pretend that I am passing an object here, and let's look at this consuming function. Here's where I'm calling my async function, and then I'm doing .then. .then wants a function, and in that function you get to determine, this is the complete function by the way, you get to determine that I am expecting for something to be back. Let's call it X. And now you can access X inside your method.
Nice.
Inside that function. Just like E, I can implement in this case, I only have a function. Let me structure this just a little bit different way. The way I like to format these when I have a few is like this. Okay, so I've got actually not ready yet. There and there. So I like to write my functions out with commas if I want to write another one. Sure. So now I can write my error function, and let's say I retrieve that one as error. There's my error function, and then here's my progress function, and this is work done. We'll call it WD. There we go. So I've implemented all three functions in this case, but like you mentioned, you don't have to. You can just say, no, I only choose to determine what's going to happen when this progress is done.
Excellent.
So when it's done, by the way, we don't have a value here. And when it's done, this function is run, and this function takes the progress bar and completes it. Sends it all the way to 100%. So this is the third strategy when using promises, which is creating your own. This is the direct equivalent of creating an async function in C#.
That's cool. Well, we went through that with hardly any of those puns. Although when you did start mentioning the promise jokes, then online I saw a lot of swearing going on. So, you know, FYI.
Well, that's because we promised that.
Exactly.
The last one is the storing of a promise. Okay, so in order to really understand what's going on with a promise, you have to understand that a promise is an object. Okay, it's an object that you can ask anytime, what's your current state? Are you done? Are you in error? And it also has some events, so you can say, tell me when you have progress. Tell me when you're in error. Tell me when you're done. That's the nature of a promise object. The cool thing is that you don't just have to have this promise object as a return value of a function. You can have this promise object, store it, and at some later indeterminate point in time, go back to it and say, hey, what's your state? That's exactly what I did in that previous example where I said, I know I'm going to want to have this thing loaded, this channel URI generated whenever the user touches this button. So I stored that promise, and then I later said my promise.then to ask, are you done yet? So I'm going to demonstrate that in great detail in this section. Okay, so here I am storing, this is a stored promise, and it's actually just, I'm setting it with the return value of long task async promise. Remember, this takes 3 seconds. So after this line runs, I now have a promise stored as stored promise that is not fulfilled. And for 3 seconds, it is not fulfilled. Now in that 3 seconds, if I were to run this line that says stored promise.then, it would check that function and say, it would say, this isn't done yet. I'm not going to execute this method quite yet. But then when that promise completes, we're going to get notification, and this function is going to be the function that runs for us. This is handy for a lot of reasons. One of them is I used it for creating code show. This screen that you see here, the main home screen, is loading a lot of different demos. And in order to load these, it has to enumerate the file system. And for every demo that it finds, it has to build out that demo and create some metadata information about it. And it takes some appreciable amount of time, you know? Yeah. And so at the very beginning, when the user first opens the app, in fact, let me just go ahead and show you that. I'm going to open default.js, and we'll look not at the test app, but at the real app, at what happens when we get into the app. And when we get here, I kick off, this event here is being fired whenever the app is activated. And when that happens, I'm loading the events, and I'm loading the events right here asynchronously, and I'm storing it as this app.demos loaded. So you'll notice that I've phrased this as a question, because anywhere else in my app, I can say app.demos loaded, then do this. And I know that that is not going to run unless the demos have been loaded. Anywhere I want, I can always say that.
It's kind of like a conditional function. You know, hey, if you are, then go ahead and do so. So that's desirable. I mean, a lot of us really want that behavior anywhere in the application.
Yeah, definitely. Okay, so the back to the promises demo, storing a promise. Hopefully that's clear. If not, drop a question in the chat room and we'll be glad to answer that. Now I've added one more thing to the promises, so let me get there. I love touching my operating system. Let me go to chaining. This is brand new, okay?
Okay.
So chaining is more of a pattern thing, a best practice thing. When you do a .then on a promise, it returns a promise. And so you can .then off of the result of it.
What?
And that promise returns a promise, and so on and so forth. Lather, rinse, repeat. So what I've got going on here is when I press start, I just get 1, 2, 3. Every 3 seconds, I get another little kick. I do something. Let's go look at the chaining that makes that happen. So I've got the wrong way, and I've got the right way. Let's look at the wrong way. It's always nice to look at the wrong way first. That way you're left having last seen the right way. So here's the wrong way. This will work. Okay? This will definitely work, but it's ugly. And it's not very maintainable. What I'm doing is I'm calling an asynchronous method, and then I'm doing a .then, and in its fulfillment method, I'm doing something. Obviously, I want to do something. And then I'm calling another long method. And then I'm doing something else, and then I'm doing something else, and you can see that I'm nesting ad infinitum here.
Right.
And at some point, I'm going to have so much indentation that I'm going to have to scroll my browser, my IDE, and that's just wrong. That's just wrong. So the best way to channel your promises is like this. And the thing that you have to understand is that the then function, it does return a promise. It returns a promise always. Now in this case, you can see that I'm doing something and then I'm returning another asynchronous call, which is what gets fired into here. I don't have to return an asynchronous call, however. I can return a string. And what it does for me is when I return just a scalar value like this, it wraps it in a promise. It doesn't return high. Instead, it returns a promise with a payload of high that is fulfilled immediately. Okay? So you can return whatever you want, and then in the next function, you can retrieve what it is that you passed up. So that value would be high down here. Okay?
That's cool.
So this lines everything up on one line, which we love to see. And you also notice that this last method is not a .then, it's a .done. Mm-hmm. What's the difference? Both of them, at first glance, look like they do the same thing.
Yep.
They both execute a function only after the promise that they're chained on has been fulfilled. The difference is that .then returns a promise and .done does not. So .done cannot be chained upon. You cannot chain off of .done. If you need to do one more thing, you need to change this to a .then. .done also handles errors, exceptions differently. So you want for it to be your last one. Now, if I made a then my last one, it would work just fine.
That's true.
But if I had any exceptions, it would see that, hey, this guy doesn't have an error function in here.
Sure.
So I'm just going to let it slide. He didn't specify what to do in the case of an error, so I'm going to let it slide. Done is not nearly so forgiving. Now if I have an exception, done says, whoa, 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 whoa. You're in a done, you had an exception, you didn't specify what to do with that exception, and so it throws that exception, and that exception will bubble all the way up to the top, and if you don't handle it, it's going to throw an unhandled exception in your app, and you're going to have to deal with that. That's the right behavior.
Yeah. I have a sneaky suspicion we'll see another example of that in the near future.
You might see another example of it. So that's promises. If there are any questions about promises, please feel free to ask them in the chat room. They do take a little while to wrap your head around, so do feel free to do that. Now, I do have a demo on web workers. Remember, promises implement asynchrony. Web workers implement parallelism. This one's also in Code Show. It's called Web Worker. And I created a little graphic. This isn't dynamic or interactive. It's just a way of trying to visualize what's happening here.
Sure.
You have the UI thread, and then we have a web worker. And if I go look at the source code, I can see both of those. So this one's called web worker. And besides web worker, actually, I should just kill this and jump into the web worker folder, because you can see that I also have task.js. So task.js is a different JS file that is actually going to be my web worker. This one's called webworker.js only because that's my convention here. I call my demos by the name of the folder. But don't be confused. Task.js is actually the web worker, and web worker is the main UI thread.
Right.
Okay. So in the demo, the boss, the UI thread, says, "Hey there, worker." And the worker says, "Hey, boss, I heard you say, hey there, worker." So it's kind of like we have, I'm demonstrating two-way communication here. The boss says something to the worker responds and includes what it is that the boss even said. So most of this demo is available, makes sense when you look at it in the code behind. So let's look at the webworker.js. Now in the webworker.js, the first thing that we need to do is create our actual web worker. So we do that by instantiating a new worker, and then we point it to the JS file that's going to use it. This is much like the background task that you were telling us about. Now, don't be confused. The web workers are not just a Windows 8 platform entity. Web workers are an HTML5 and JavaScript 5 entity. So this is just the implementation in the Chakra engine of that. Okay, so now this is how the web worker talks to us, and this is how we talk to the web worker. So first, let's say if the web worker says anything to us, we want to log it on the screen and talk about what the worker said. The worker said, and then here's the data that he passed along. This is how we talk to the worker. We say, "Hey there, worker," by using this variable that we instantiated and doing a post message. Okay, now you could drop in here anything you want. So I just said, "Hey there, worker," but I could call that message, "Hey there, worker," and I could add time, and I could add severity, all kinds of stuff. I could create myself a nice, rich object there. Okay, so let's go look at the task.js now. The task.js is not a JavaScript file with access to the DOM. Okay, you cannot do document dot whatever in here because this is separate. This is a worker. Now this is how the main thread talks to us, because the one and highest level thing that we do in our worker JS is we say me, self, on message, do this. So in other words, in order to kick this off, in order to start a bunch of work, in order to do anything, we want to kick this off to the web worker. This is the function that's going to run, and it's the main thread that's going to post a message and say this needs to happen. So now, when that happens, this worker, his only job in life is to chatter back to his boss and say, "Hey, I heard you say this." So once again, when you run that one, this is just a graphic, but you see here that it's actually worked. The worker said, "Hey boss, I heard you say, hey there, worker." I don't know what you would call that sentence structure. It's a little bit of a who's on first, or I don't know. It's a little bit strange, but hopefully it relays that two-way nature. Now, there's one more thing that I'm only going to talk about briefly, and that's one more tip for adding a lot of performance into your application, and that is reactive extensions. Reactive extensions are super exciting. It's a cool topic, and the nice thing is that there is an instance of reactive extensions for JavaScript. Okay, so just go do a Bing on reactive extensions JavaScript. The kind of the shortcut handle for it is RxJS, and you'll find all the extensive documentation on RxJS. Okay, now I'm going to run. There are a few demos in CodeShow that show off reactive extensions, and they all begin with Rx. So there's an autocomplete, canvas paint, crop, drag and drop, time flies, and they're all pretty cool. You know, you get like the time flies actually follows some characters around on the screen, and that's pretty cool. The cropping gives you a little crop utility that allows you to determine a certain section of a picture. The drag and drop looks, you know, like a no-brainer, but actually, you know, drag and drop takes some kind of framework or something to happen, and this is actually doing it in reactive extensions. Quite cool. Cool. The one I want to show you above the others is Rx Canvas Paint. Canvas Paint is giving me the ability to draw, but it's not using any control or anything like that. It's just using Canvas and JavaScript. That's it. But in that JavaScript, I'm subscribing. Let's go look at the code for this, because this is pretty neat. This one's called Canvas Paint. And in Canvas Paint, in the JavaScript, you'll see that we are jumping into the Canvas's mouse move event, and we're creating an Rx observable out of that. Okay, so we're converting an event to an observable sequence. This observable sequence now, we can run all kinds of Rx functions on it, and they can help us to do really awesome stuff. Okay, so now mouse moves is an observable, and so with mouse diffs, I can access that mouse moves, and I can do fancy things like I can buffer it, which means don't just tell me about each event, each movement of the mouse, and that one event alone, that one instance of it, but instead collect two of those and tell me about both of them. That's because whenever we draw on the screen here, we're actually drawing a lot of little lines between one point and another. Sure. Lots of tiny lines, okay? So that's why we need to have that buffer count. And then off of that buffer count, we can select, and select is just a projection. We can turn this into anything that we want. So in this case, we want to turn it into a value called first, that is the offset of the first point in the buffer, and then second, which is the second point in the buffer. We can then, so that was all about the mouse move. That was just moving around on the screen. I'll do that with I can't do that with touch, but this is just mouse move. That stream is active as I move this. But when the user puts his mouse down, we now have a different stream. So we're capturing that as an observable. We're projecting that as well to just a true value, meaning I want a stream of trues, meaning the button is down. Okay? I can then merge the mouse up with the mouse down, the mouse up being return false. So now I have a stream that I've composed that is true when the mouse button's down and false when the mouse button is up. Wow. And all of the garbage collection and the event listener removal and all of this maintenance work that you have to do usually when you subscribe to series of events, is all happening for you. You don't have to worry about that. Okay. So now painting is just a matter of grabbing that mouse button and then selecting the difference in the mouse moves, and then painting a line in the canvas as a result. Excellent. So get reactive extensions on your radar. Make sure you know about it, what it is, when you would use it. It's a lot to dig into just because it's huge and powerful. But when the time is right, when you've got something that needs it, there's no replacement for it. So go look up RxJS and have fun with it too. It's a blast. Whoa, that was kind of big, huh? Yeah. So here we talked about all different kinds of ways to make sure that your UI is responsive, and now you're going to tell us about some other ways to kind of offer some fast, fluid, and alive behavior, right? Sure.
Yeah, so if we take a look at the screen now, we can see that we're looking into implementing animations and transitions. And the brief story there is, think of animations. People can think that they're kind of one and the same, but really their intent is different. An animation will enhance the user experience somehow, where a transition is usually an indication of some kind of visual state change. So when you think in terms of that, it's helpful. Sometimes the nomenclature seems to get mixed up, but in terms of, CSS3 transitions and animations, it's very true that you have a lot of control over what will be done in an animation, and it can be invoked entirely on your own will, where transitions are usually invoked by something that changes, a visual state of some kind. So what I thought I would do now is take a sneak peek into the Code Show app, and specifically I'll go ahead and run it. We're just going to see a brief example of both of an animation and a transition, and the key here is both of these are CSS3, and they're not tied or bound in any way, shape, or form to just something specific to Windows 8. So the first is animations. Now, this may have been seen before. This has been in Code Show for a while, but the idea here is clicking on this is going to invoke the animation. And it says, don't click me, it makes me angry. So, of course, we're going to do it anyway. And the animation is changing multiple things, and you'll notice it went at various speeds. The magic behind that, if we were to examine the code, which I'll go ahead and do from the Visual Studio perspective, is in the CSS file for that animation. So when I cruise into the animation CSS, it's done through keyframes. And basically this means at 0% do this, which that's the starting point. Then when you get to 60% of the journey, do this. That means between 0 and 60, it's got to do a transition, so to speak, between these two steps. Then between 60 and 80%, it has to do a transition of these steps. And it goes all the way to 100%. You can also have some very simple ones, such as 0 to 100%, to just do one simple type of animation. Start to beginning, move something. So that's what that's there for. That drop-in is, of course, if I believe it was invoked the moment that we clicked on one of the titles or something like that. But I'm going to go over now to the transitions and show how that would be different. Transitions, when I press this, what is happening is it's going to change a class for this, and then it says, oh, you click me, keep pressing, okay. And then I kept pressing, and now it's saying let go, and it just vanishes. Each one of those transitions was invoked by something, and it was a state change that happened inside of the JavaScript that changed some state about the data itself, some of the visual state. So you could do this, by the way, anytime you change a class name or you change a specific style. If your CSS3 for that particular file actually is impacted by that change, which I'm going to show you in that transitions CSS3 file, what I am saying right here is anything that happens to that box, transition it for 4 seconds. And the all means anything that changes, any kind of behavior, CSS3 type behavior that changes, go ahead and transition. So as we go forward, we can see that when other classes are added, they may have their own type of transition delays or their own kind of transformations. So that's how you would accomplish this here with pure CSS3, and that's what this is. However, going back here to our demonstration, the other thing that you'll want to keep in mind, which can be very handy, is to implement the winjs.ui.animation API. Now, this one is, of course, tied to your Windows Store application, and it can handle some very desirable animations and transitions very easily. So let me go back. In fact, while I'm in Code Show, Mr. Foster, where was it that you had that really good example of, some dynamic stuff?
Go all the way to the right.
All the way to the right.
Other side.
The other right.
The other right.
Okay.
And look at template items.
That's right. In template items, it says click a letter to remove it. Now, watch closely when I click on B. You see, everything kind of moved around very nice. It was very easy to see, but there's a slight animation that's going on. This was not done through exhaustive CSS3. This was done through an API call. In fact, if I were to go just visit that code and then cruise over to the JavaScript for this.
You can touch it.
I forgot. I love that. Let's see. I'm trying to see where you, create add to list animation from the win.js.ui.animation is right there. So very easy for you to make. Instead of him worrying about all the metrics of everything, it's just done. So very nice there. So that is our win.js.ui.animation. And the other thing that I would want to make sure everyone is aware of the fact is that there is an MSDN sample that you can go to where every single one of those MSDN animation types is there. In fact, I'll just load it real briefly. Again, you would do this by going File, New Project, and going to Online, but I already have one that I've loaded, which is the demo animations. And without showing you the code on this, but you just seeing the idea, transitioning, like expanding and collapsing. If I expand, you can see the expanded area. If we add an item or delete an item from a list, all of the different types of animations that I'm just briefly showing, they're usually just one-liners from that API call. So if you're interested in some of the behaviors you've just seen, just get that animation library, JavaScript sample, and you can do that, of course, by just going to Visual Studio, New Project, and there you have it. You look for that HTML animation library sample. Okay.
So it looks like we need to cover a little bit of information about custom controls.
Yes.
So custom controls is a fun topic for me.
Why is that?
It allows me to make, allows me to make things modular. I consider myself an architect. I kind of think that way. I want things to be not just written in a way that works, but written in a way that makes sense and it follows all of the standard principles. And as we all know, one of the standard principles is be dry, right? Don't repeat yourself. Don't write code in multiple times when there's no reason to. And that's why we want to use custom controls. Now, custom controls are real analogous to the controls that are created when you create custom controls in ASP.NET. So if you have any experience with that, the concept is going to be roughly the same. You're looking at some hooks behind the scenes that basically allow you to determine what happens when a user instantiates this, allow the user to pass in some properties, and by user I mean the developer, pass in some properties, and then determine what a control that's instantiated like that and given those properties is how it's going to render itself, okay? So that's the general concept. Now, to show this off, and I'm a little behind in my slides here. Sorry about that. Custom controls, that's me. So you don't want to find yourself repeating yourself ever. That's important. Not to repeat yourself. And also when you want to share a UI component with somebody else or you want to like package it up and deliver it, that's another good reason to use it. Okay, so I've got a demo called Custom Control. It's in Code Show, surprise of surprises. It's called Custom Control, another big surprise. And this is what it renders like. This is my big box control, okay? It's perhaps the simplest custom control I could think of. Let's make a big box, that's it. Now, the thing I want to show off is the fact that one of those boxes is black and the other one is green is significant because of the way that I've consumed that custom control. But before we get there, I need to show you how to write the control itself. You can do this anywhere in your project, but if you're working on a big enterprise app or you're working on your own app and you've got a number of controls that you want to create, you might have, say, a controls folder at the root directory, and this is where you drop all of your controls. You give them a good namespace, and then you get to utilize them wherever you want. Okay?
I'm just curious, real quick. Why do that? It seems like wouldn't just a div that you make be reusable, or like that, a custom control is just your own custom defined area on a page, isn't it?
Yeah. Now, if you write something inside of a div, then you could call that a custom control, right? It's custom code. But you're going to have to use what we like to call clipboard inheritance in order to get that custom control to exist in multiple locations and to have perhaps slightly different behavior. Let me give you the example of, let's say we're making a shopping cart, and on the page where we're filling out all of the particulars, like our credit card information and so forth, we've got the shipping address and the billing address. Now, this is two different instances of the need to collect address information. Now, you could certainly write a div that had some input controls for city, state, zip, that has a drop down for the state, and a lot of different things. But then you're going to have to copy and paste that. And then the next time you want to change something about it, you're going to have to change both of those.
Right.
Now, you could give yourself, if you're writing a custom control, a little bit of a really smart functionality where you give the user the ability to choose whether what country they're in and how they want this address to be formatted. And now you're giving some intelligence to your control. And so if you don't make a custom control out of that, then you're repeating all of that logic that determines that behavior. So that's not what you want to do. So that's why we use a custom control instead of a div. So let's look at under demos, at custom control. And in custom control on the HTML, here's what I have. I simply have a section, and in that section I have a div, and we're going to come back to that in a second. I'm going to take you now to customcontrol.js. Now, the structure of this page is important. If you were with us before, I think in 481 most likely, we talked about the modular pattern in JavaScript apps. And so technically we'll assume you know that, but just as a quick review, this function at the top with this little football at the end means make me a function and run it. And the reason that we do that is that everything inside here is scoped inside here. And inside of here, we're defining a page. And the definition of a page gives us the opportunity to define what happens when that page is ready. So this function gets called whenever a page is ready. The DOM is loaded, and it's good to go. But outside of that page definition and that ready function, we want to do something else. Now, this is still only available within the scope of this page, or it would be if we weren't using win.js.namespace. Win.js.namespace kicks us out of this box, this function scope, and instead defines at the root directory this custom control namespace. Okay, so whatever you want the namespace of your app to be, maybe this is my app.controls.ui.controls, whatever your namespace is going to be, that's what you put right there. Okay? So we'll just call that custom control namespace. Now, a namespace is expecting a definition, and if I collapse this, you can see that, well, it's a little hard to see, but this definition is expecting the name of the namespace and an object. So here's the beginning of the object, and here's the end of it. Okay? So it's expecting an object, and that object that we're giving it has the name big box, and here's what the object is. It's a class. So here we're using Win.js namespace and Win.js class. Two Win.js implements in the same two lines of code. Now, you know that most people that write in JavaScript either find a way around the need for classes, or they use some kind of library that provides them classes. And Win.js provides us namespaces and classes and does a dang fine job at it. So we just hop into there and use that. Now, it wouldn't have to be this. As long as it adheres to the pattern, it'd be fine if you used whatever else. But in here, the first thing that a class wants is a constructor definition. In this case, the constructor needs two, and this is important, it needs two parameters, element and options. I'll show you why it needs those in just a second. Then we define what happens in the constructor, and then we provide some of these member variables. So now let's go look at the HTML file again. I was telling you that we've got a control here, but what makes this a control? This looks like just a div, right? It's just a div, right?
Exactly.
But it has a special convention. It has a data-win-control attribute. And when a div has that, it gets targeted by the process method. You might not even have known that the process method was running, but if you go to the default.js in your app and you jump down, you'll find at some point in here that this WinJS UI.processAll is being run. And that's a super important method. Without this running, none of your custom controls get built out. List views are just funny looking divs, and pretty much nothing in your app will work. Not nothing, but very little of your app will work. Now the second attribute, and this is a custom data dash attribute. Remember that data dash attributes are valid HTML5. Anything that begins with data dash is considered valid HTML5. Now the Windows group decided to use data dash win dash to say not only is this a valid custom attribute, but it's also a Windows custom attribute. Okay? So controls always have control and options. Always have those two. Now in this case, we're specifying that the control is custom control namespace.bigbox, and the options is a JSON object. Or technically, it's just a JavaScript object notation, but it looks like a JSON object. It's an object with curly braces. It's like a left mustache, right mustache. And inside there, a number of properties, those properties with values. Very simple, but it's this is our opportunity as the consumer of a custom control to pass in some things that we want to use to customize that control. So as you saw in the demo, we had a black box at the top, and that's because we passed in an options value of background color black box, or black. Okay? Now, where did we get our second box? This comprises the black box, but where did we get the green one? Well, for that, I'm going to take you back to the custom control.js, and if you look above the namespace definition, the definition of our custom control, and you look in the ready method, you'll see that we are doing something fancy here. We're creating a div with just standard JavaScript, document create element div. And then in there, after that, we're creating a big box, a new big box. We're calling its constructor, give me a new big box, and it needs you to give it two things, element and options. That's why we specified those. Keep going to the wrong one. Here, element and options. So we pass in the element. The element is just that element that we just created. We pass in the element, and we pass in our options. So this time we're specifying green. And then we've just created a div, and it's going to look like a big box control, but it's not going to show up anywhere unless we go grab something, like in this case the main section, and then append that div as a child. Hope that's clear. That gives us the declarative approach with the black box. That's on the HTML, the declarative approach, and it gives us the imperative approach. And you can use whichever approach or some combination thereof. The framework really doesn't matter. When you create things like list views and whatnot on your HTML, remember that you do it like this. Same syntax, except you call into the WinJS framework. They just have controls that are created for things like the list view. All right. So that covers the custom control. Next, we're going to talk about apps, designing your apps for globalization and localization.
That's right. In fact, if you were to swap over to my screen right now, I am already in a Visual Studio project. This is once again an MSDN sample, and this one specifically you would just search for globalization. So I'm going to run it so that you can see what the win is and why we're talking about this. You know, I personally think it's a fascinating time to be an entrepreneur, and especially with regard to application development, because my goodness, the world is shrinking in terms of our audience. And when I say shrinking, I don't mean that the population is going down. It means that our accessibility to them has increased. It's shrinking from the perspective that we can go find people that could be consumers of our apps that we've never seen before. So a part of that strategy to make sure that we're not maybe too narrowly focused in our own world is that we're thinking about how things are presented globally. How would your app appear globally? Well, you could say, well, it appears just the way it does. And that could be the problem, because maybe that's not conducive or helpful to somebody who's using your app who might be based in another country where they don't speak English as a primary language. So, or not only that, but even how they represent their currency, their date, their time. All of those kind of things are what you need to think about when you're putting your app out there. This was something I had to consider when I published the Tile of Time app in the store. Will that be beneficial to somebody from another country that needs to see their date and time in another language? So I had to factor that in too. So I want it to be beneficial. So what can you do? Here's a key. In the globalization, you want to be able to make sure that if you're going to display, let's say, your date and time, that not only you have control over the formatting of the date, but it's going to format in your language, in your culture. Now, there are various ways that you could do that. Just by clicking here and saying use a string format, and when I click display, it looks like it's kind of displaying the same things. However, and I'll show you this in a moment, when I go over into Visual Studio to look at a brief look at this, you'll see that what we're really using is something that I posted in the online Q&A area. It was a link about using the datetime formatter. So hopefully you have that and you can see that available. In fact, when I switch over to that screen over here in Internet Explorer, you'll notice that one of your options is to use a format template, and the format template has all sorts of already predefined ways that you can extract either just the year or the day in the month, the day in the year. So it's a whole bunch of different ways that you can extract that. But the benefit for you when you're using this is that it will actually display that format in the language appropriate to whatever the user's culture is set at. Now, overriding the current user settings is possible as well. You may want to explicitly display something from another culture, which is what we're doing right here. This is based on today, but now we're seeing this in other national or other languages. And so how is that all done? Well, when I go back over to Visual Studio, I'll go ahead and stop this and just take a look at some of the examples. I think the key one that might be helpful, or two of them that might be helpful, is to look at the override settings, the one that we just saw. And this is the one that says, I want to actually create a date-time formatter. That was that link I put in that Q&A. I want to have the long date style, but I want to be able to define either French or Japanese. So this is how you can go in and be very specific if you want to override whatever the user's settings is. You'll notice that here we're using some of those named templates. Yet another option that we have is to use strings. And what we mean by that is probably a lot of you are familiar with passing strings in. Maybe you've seen a format like in an Excel where there's like MMM for month, maybe number versus a small abbreviation. Well, here we have month abbreviated, we have month, and it's just a little bit different than what you're probably used to in terms of maybe using that smaller format, but it is available nonetheless, and once you get the hang of it, you can still have that kind of control over all these datetime formats. So I'm going to completely snap out of the globalization aspect of it and unload this project and load in the localization example. So you're going to hear terms like globalization and localization. I like to think of globalization as everything that has to do with the surrounding cultural type things like date, time, currency. That, globalize your app in terms of those things. But what about the actual your own custom messages that you want to put into, error messages or the verbose statements in your app? There isn't something in the system that knows what your app meant. It can only translate some of those things like date, time, and so forth, and currency. So here is where you have an opportunity to provide that transition. And here is the short of it. In this localization one, another MSDN sample, underneath the, or as a folder in the project, there is a strings folder, and inside of that strings folder, you will notice, if I zoom in on there, there is a variety of folders that inside of them, they're all going to have the same files in them. They're going to have the same named files in them. So I'll expand one so you can see what I mean. Whichever country code languages we support. So in this example, EN-US means English for US, because you know there could be EN-UK for the United Kingdom. There's other countries that speak English, so if we need to be very specific to which country we're referring to, that can help also for us to put maybe different words, even though we all might speak English, we might have different way of saying things. So let me expand that, and you'll see that I have in here 3 different files at this time: errors.resource.json, then just resources.json, and then resource.json. The key here is these resource files can help us to have a pattern for how we will input various statements. Let's look at the English version here, where it says, if we have something here called scenario 5 error, which we'll call the label of what we want, this is the message that gets returned. This is a localized error message. So if I were to run this and go to scenario 5 and then show the text, that's exactly what I'm going to see here. Now, had I switched the settings of my machine to be, let's say, Japanese, then it would not call the English one. It would have automatically called the other one in the file that is in our project right here. So I'll zoom into there again, and it would have gone to that one. So notice that the label remains the same, but the content that gets displayed is what's different. So for each one that you want to support, that means each language you want to support, you would need to create a corresponding folder. You copy, the practice is get one language down first. You don't want to be making this an iterative thing with all of them. You get one down, get it solid, and then you can start adding the other resources. This one here is an example of how you can load multiple resources. So these are labels, but notice through this convention we have here, not only do we have the label, we can also provide a comment. And the reason why this is important is because this is the actual statement, but this can be beneficial for translators. Someone's going to have to come along and translate this thing. Someone has to. Someone has to know. I don't know Japanese, but I might be able to give somebody who is an English to Japanese translator some comments as to what I'm hoping to accomplish by that statement. It's extra metadata. Now, what they would do is they would take this, and then they would create a corresponding file over here, let's say in the Japanese, and you would see all of that appear here. With time lacking, there is so much that we can go into this area, but I want to hit on one really cool, important piece. You can programmatically access these. You can also refer to them declaratively. Take a look even in our package manifest file. That ms-resource : is actually indicating that the display name of our app is going to be dependent upon what did we put in one of those resource files. And of course, if I were to go check, that means I must have one called app display name. So I would go over to the resources and say, do I have an app display name? And scroll down, and sure enough, I do. And it would say application resource JS SDK sample. And then we can change that for each corresponding language. So highly recommend that, that you look into the globalization and localization samples. They're awesome. They're complete. And one other thing, and I think I put this into the Q&A, and that is take a look at this as well. This is not needed for the exam. What I'm about to show you is not needed for the exam. It's just a recently released toolkit that can help you with the translation. So this is more of a real world thing. take a look at the Multilingual App Toolkit. It also makes it very easy for you to test using a phony language. Want to know what I mean? You better check out that toolkit. So I think that's going to have to wrap it up.
Yeah,
we've gone
plenty.
for quite a bit, so yeah. I think we'll wrap it up for a break.
Module 5.
And then we'll be on to Module 5.
All right, thank you.